For today's lesson, we're talking about linear relationships, finding slope from graphs. Our essential question is, what is the slope of a linear relationship, and how do we calculate it on a graph? Please take a moment, pausing the video if you need to copy down the topic and essential question in your header, along with today's date, set up your question column and your note column, and resume the video when you're ready to begin. So let's start today by defining the vocab used in our essential question here, linear relationships, and slope, which is a new vocab word. So let's dive in and get the definition of these two words. So linear relationships is a relationship between two variables, an input variable and an output variable. Usually we use x and y to represent those variables, especially when graphing. And the thing that's special about this relationship is that it has a constant rate of change, also known as slope, that forms a straight line when graphed. So we've been looking at a special kind of linear relationships called proportional relationships, and so now we're going to look at some that are still in the family of linear relationships but aren't necessarily proportional. And here in this definition we see that slope is rate of change. But what exactly do we mean by that? Well, when we're talking about rate of change, which is also given the vocab word slope, we're comparing the vertical change to the horizontal change when we're looking at it on a graph. And it's written as a ratio in fraction form, and so since our y-axis is the vertical line on the graph, the vertical change, we look at the change in y. That's what that little delta symbol means. It looks like a triangle, means change in y. And that's in our numerator, and in the denominator we put the change in x, because x is the horizontal change on a graph. So let's look at 4 different types of slope for linear relationships. So every linear relationship can fall into one of the 4 categories of slope. So we have positive slope here, negative slope, and then the last 2 examples would be a zero slope and an undefined slope. So we're going to look at each of these 4 types of linear relationships and calculate the slope and see what makes each type unique. So let's focus in here on our first graph of an example of a line with positive slope. What's important to note about the slopes and how we read them is we always start from the left side of the graph here and read them to the right. And a positive slope will always start low on the left and then start rising up as we read it to the right. So we can see this line is increasing, which makes it a positive slope. So what's important as we get ready to calculate what the actual slope is, which tells us how steep it is or how fast it's changing, right? That rate of change. We need to find the vertical change and the horizontal change between the points on the line. So please make sure that you have this graph copied in along with these points. Here's our y-axis and our x-axis. So I would plot these 3 points and then use a straight edge to draw a ruler through them. And then we'll calculate the slope. Alright, so we have the slope here where we're going to calculate it, and you'll sometimes hear it described as rise over run, because the change in y, that vertical change, is how much it's rising or dropping compared to how much it's running, the horizontal change on the x-axis. So let's see what that actually looks like. So hopefully your graph is copied in. So what we want to do is we want to find our points, and so we're first just going to think about this as stairs. So how much does it go up, right? How much does it rise, or how much is that vertical change? And then how much is its horizontal change, the run? So from here, between these 2 points, it goes up 1, 2. So that would be our change in y. And then it runs 1, 2, 3 to the right. So this would be a 3. And you always want to check to make sure it should be the exact same between any points on the line. So if I then look at the next 2, it goes up 2, 1, 2, and so again it goes up 2, and then it runs 1, 2, 3. So that's the exact same. So the slope of this line is a positive slope that is 2/3. Okay, let's go ahead and take a look at negative slope. Alright, so here's our example for negative slope, and once again, please make sure that you draw in this accurate graph, that we have our y-axis here, our x-axis, and then I would plot these points, -8, 5, -4, 2, 0, -1, and then I would use a straight edge, a ruler, to draw the line through those 3 points. And we'll go ahead and define what a negative slope is, and then calculate it from this graph once you have that drawn in. Okay, so a negative slope, again, is based on how we read a graph, reading it from the left side to the right and watching what the line does. And so any line that starts higher on the left, and then as you go to the right, it starts dropping or decreasing and gets lower by the time you get to the right side, then that is a linear relationship with a negative slope. So we're once again going to calculate the vertical change and the horizontal change between these points, and we'll notice now that instead of rising, it's actually going to be dropping between each of these points, the vertical changes, and that's what gives it that negative slope, that negative value. So let's go ahead and take a look at that. So we'll start here with our first point. So it goes down 1, 2, 3. So I'm going to actually write that in because it went down. I'm going to write that as a -3, just like when we were doing translations. If we moved it down, that was a negative movement. So it's going to drop 3 as our change in y, so I could write that in here. And then our run, our horizontal change, is always to the right, and so we start here where we left off and see how far does it change horizontally, and that is 1, 2, 3, 4. So it has a horizontal change, or a change in x, of 4. So it looks like the slope value, the steepness of this line, is -3/4, and of course we want to check to make sure that it's the same between any 2 points. So if we check, it goes 1, 2, 3, so we see another negative vertical change of -3 and a horizontal change of 1, 2, 3, 4. That's the same, so we got -3/4 again. So here, in our example of a negative linear relationship, we calculated that the slope, the steepness, is actually -3/4. Okay, so we should have that all written in for our example on negative slope. Let's go ahead and take a look at our third example, zero slope. Alright, so zero slope, you might have some guesses here as you look at our graph, and again, here's our graph. Our y-axis is right here, our x-axis is running here. Every grid line counts as 1, and we're using the points -2, 3, 0, 3, 2, 3. So again, draw on that graph, plot these points, and then use a ruler to draw your line, which you might notice is just a horizontal line, through those points. So a zero slope, as you can see here, and as you already heard me describe, is just a flat horizontal line that actually has 0 vertical change, which is where it gets its name of zero slope. So as we looked in our first 2 examples, between these points, we were either rising, right, for a positive slope, or dropping for a negative slope. But if you look here, we don't rise or drop at all between these points. So there's 0 vertical change, but we can see some horizontal change, and in this case it goes 1, 2 to the right between those points, and so our vertical change, our change in y, would be 0, and our change in x, our horizontal change, would be 2. Let's go ahead and write that in. So here we have that written in. Again, our vertical change, our change in y, was 0. It didn't rise or drop at all. And our horizontal change, our change in x, was 2. Well, 0 divided by any number is what? 0, right. So anytime you have a flat horizontal line, you can automatically know, really without doing any calculations at all, that the slope will always be 0. Let's take a look at our last example. Alright, for our fourth and final example, we are looking at undefined slope. Here's our graph again. Here's our y-axis and our x-axis. Please draw in the points -2, 0, negative 2, 2, and negative 2, 4. Plot those points and then draw a straight line through them for this example. And while you do that, I will uncover the definition of an undefined slope. So any vertical line that has, in this case, no horizontal change is always going to be considered an undefined slope. But what do we mean by undefined? That really comes into when we start trying to calculate this. So let's once again calculate our slope with the change in y and our change in x. So typically I would try and figure out, like, as I've been mentioning, we read the graph from left to right, and we start with whatever point is furthest to the left to read that and calculate our slope. But these are all equally as far to the left, so I'm just going to start with the top point here. So I'm going to start at negative 2, 4. And so it would look like we have a vertical change. That's always what we calculate first, that change in y, where it is dropping 2. So I'm going to write that as negative 2. And if we look, that happens again here, negative 2. So we would write in for our rise or our change in y that is negative 2. But what is our horizontal change, our change in x? Well, they're all stacked on top of each other, so there is no change. So in this case, it's the horizontal change that is 0. It's not moving left or right at all. So far we have our slope written in as negative 2 over 0 as our rate of change. So think about that for a minute. If you take any number and you divide by 0, what happens? Any ideas? What happens when we divide by 0? Sometimes students will tell me that the answer is 0, but that would be incorrect. So let's just take a look. So if I have negative 2, and I am dividing that by 0, I get an error message or something similar to this one that says we cannot divide by 0. Mathematically, we cannot have 0 in the denominator. We can't divide by it. So this is why a vertical line has an undefined slope, because the change in x is 0 and we cannot divide by 0, so we simply say that the slope is undefined. So that is going to conclude our video today on the 4 types of slope and how to calculate it from a graph. So please remember to write in your summary, make sure that your graphs and slope calculations are complete.